Click on the Add Data button. Navigate to the MGIS Data folder and open the World folder. Click on the country shapefile, hold down the Control key, and also click on lat long. Click Add to add them both to the map. Click twice slowly on the layer's data frame name and type in World. Press Enter. Right-click the country layer and choose Properties. Click the Source tab. Examine the extent and the coordinate system for this feature class. Close the Layer Properties window. Observe the coordinates shown in the lower right of the window. Confirm that they are in decimal degrees. They defaulted to the units of the coordinate system of the first data set loaded. Click the Zoom In tool and zoom in to the corner of Florida in the United States. Use the cursor to hover over the tip and read the coordinates. Right-click the World Data Frame name and choose Properties. Click on the General tab and examine the entries for the map units and the display units. Set the display units to miles and click OK. Examine the coordinate readout now. Click on the Full Extent button to see the whole world again. Then right-click the World Data Frame and open its properties. Click on the Coordinate System tab and notice what it is set to. In the folder tree, scroll back to the top and collapse the Geographic Coordinate Systems folder. Then expand the Projected Coordinate Systems folder, and also expand the World folder. Scroll down and find the Mercator World Projection and click on it to select it. Examine the map parameters, including the units, and click OK. Click on the Zoom In tool and zoom in to the tip of Florida again. Look at the display units at the tip and notice they're now in miles because that's how you set them. Zoom back to the previous extent showing the entire world. Move the cursor over the map and keep track of the coordinates. Try to find where the values are approximately 0. Click on the Add Data button. Navigate to the USA folder, open it, and open the US Data Geodatabase. Click on the States feature class and click Add. A Geographic Coordinate Systems warning window should appear. Read through it and then click the hyperlink to get more information. This will open the help. Read through the help to find out what is going on. Close the help window. Click on the Transformations button. The layers are in these two geographic coordinate systems, and you could convert all of the data to one of them. However, for world data, the errors introduced by this conversion would be small relative to the data sets, so we will not apply conversion at this time. Click Cancel. Check the box Don't Warn Me again in this session, and click Close. Double-click the States layer to view its properties, and click on the Source tab. Notice that its coordinate system is North America equidistant conic. Take a look at the other parameters and answer the questions in your book. Then close the layer properties. Double-click the World Data Frame to open its properties. Scroll up to the top of the list of projections. Collapse the World projection and find the Continental folder and open it. Open the North America folder. Find the North America equidistant conic projection and select it, and click OK. The world map will look strange, but remember this coordinate system is designed just for North America. Click on the Zoom In tool and zoom in to North America, including Central America. Right-click the lat long layer and choose Label Features to place the values of the longitudes and latitudes on the map. Use these values to find the central meridian, the standard parallels, and the origin of the map based on what you wrote in your book. Double-click the World Data Frame to open its properties and select the Coordinate System tab. Collapse all the folders until only the main four are shown, and then expand the Layers folder. Expand the plus sign next to the GCS to see which layers have that coordinate system. Click the GCS to set the data frame to that coordinate system and click OK. Click the Full Extent button to show the whole world again. And right-click the lat long layer and choose Label Features again to turn off the labels. Click on the Add Data button. Navigate out of the US folder and open the World folder. Click on the circle shapefile and click Add. Make sure that the table of contents is set to the first icon. Then click and drag the circles layer above the lat long layer. Double-click on the World Data Frame to open its properties, and move it aside so that you can see both it and the map. Collapse all the folders, and then open the Projected Coordinate Systems folder and the World folder. Find the Mercator World projection and click to select it. Click Apply to keep the window open while still changing the coordinate system, and examine the map. In the Data Frame Properties, find the Robinson World projection and click to select it. Click Apply and view the map. In the Data Frame Properties, find the Sinusoidal World Coordinate System. Click to select it and click Apply. Examine the map. In the Data Frame Properties, scroll up and find the Continental folder and expand it. Then expand the Africa folder. Choose Africa Sinusoidal and click OK to change the coordinate system and close the Data Frame Properties. Click on the Zoom In tool and zoom into Africa. Double-click on the World Data Frame to open its properties and click on the Coordinate System tab one more time. Collapse the Continental folder and expand the UTM folder. Navigate to WGS 1984 folder and expand that. And expand the Northern Hemisphere folder. Find the zone for 35 North. And click to select it. Click OK. Click on the Add Data button and find the UTM Zone 35 shapefile. Click to add it to the map. Click on the symbol for the UTM zone layer. Choose the hollow symbol. Give it a thicker outline and change the outline color to a dark orange. Click OK. Click on the Save button to save this map document, and then click on the New Map button to open a new map document. Choose the blank map and click OK. In the catalog tree, Find your New Jersey project folder and expand your New Jersey geodatabase. Right-click the NJ Cities feature class and choose Properties. Click on the XY Coordinate System tab. It is really important that you not change any of this information here, because then you will have a mislabeled data set. After you've examined the coordinate system, noting that it's in North America equidistant conic, where it should be in a New Jersey coordinate system, click Cancel in case you accidentally change something. Open ARC Toolbox. Expand the Data Management Tools and the Projections and Transformations toolset. Find the Project tool, not the Define Projection tool, and double-click to open it. Using the catalog, find your New Jersey geodatabase. Click and drag the NJ Cities feature class into the Input Dataset box. The original coordinate system will be listed. Click on the Browse button for the Output feature dataset. Navigate to the New Jersey geodatabase if necessary, and enter the new name NJCities_SP to indicate that it's an estate plane coordinate system. Click Save. Click the button to set the output coordinate system. Navigate to the Projected Coordinate Systems folder, and then expand the State Plane folder. Find the NAD 1983 meters folder, the plain one that isn't any of the specialized ones. Scroll down and find the New Jersey State Plane Coordinate System. Click to select it, and click OK to choose it. Check your entries against the figure in the book, and then click OK to start projecting. Open ARC Toolbox and double-click the Project tool to open it. Click and drag the New Jersey Districts feature class from the geodatabase for the input features. Click the Browse button and name the output NJ Districts_SP. Click Save. Click on the Output Coordinate System. Click on the layers, and you can use this to set it to New Jersey State Plane more quickly. Choose OK, and click OK to run the projection. Click on ARC Toolbox and open the Project tool again. From the catalog, add the Major Road Clip feature class and drag it into the input box. Click on the Browse button for the output and name the output Major Roads_SP. Click Save. Click on the Browse button to set the output coordinate system. Expand the Layers folder and choose the New Jersey State Plane Coordinate System. Click OK, and then click OK to run the tool. In the table of contents, double-click the first feature class, click on the Source tab, and check to make sure that it's in New Jersey State Plane. Click OK when you're finished. Click on the major road, check the same thing, and click OK. Click on the final one and ensure that it also is a New Jersey State Plane, and click OK. Finally, check the data frame coordinate system and confirm that it is also set to New Jersey State Plane. Click OK. In the Catalog tab, right-click the old NJ Cities feature class and choose Delete. Click Yes to confirm the deletion. Also right-click the old New Jersey districts and delete that as well. Click Yes to confirm. Finally, right-click the original major road clip coordinate system. Choose Delete and click Yes. Click on the New Map File button and choose a blank map. You don't need to save your current map. Click on the Add Data button. Navigate up to the MGIS Data folder and open the Black Hills folder. Then open the Sturgis 83 geodatabase and the Features Feature Dataset. Click on the dataset USFS Roads and click Add. Double-click the new feature class to open its properties. Click on the Source tab and write down the name of the coordinate system and the datum. Also examine the range of coordinates in the extent in the upper part of the window. Then click OK to close the Properties window. Click on the Add Data button. Click up to get out of the Sturgis geodatabase and open the Downloads folder in the Black Hills folder. Click on the county line shapefile and click Add. You will see a warning window that it has an unknown spatial reference. Click OK. The layer appears in the map, but you can't find a county line. Perhaps the symbol is too small. Click on the symbol and change it to the highway symbol to make sure you would be able to see it. Click OK, but you still can't find it. Right-click the county line layer and choose Zoom to Layer. Here's the county line symbol, but it doesn't appear to be with the rest of the data. Open the properties for the county line layer by double-clicking on it, and click on the Source tab. Examine the coordinate system and extent carefully. You already know that the coordinate system is undefined. The values in the extent are very small numbers, less than 180, which is a sure sign that you are dealing with an unprojected coordinate system or a geographic coordinate system. Close the Layer Properties window. Open Arc Toolbox, expand Data Management Tools and the Projections and Transformation tools, and double-click on the Define Projection tool. Set the input data set to county line, and click the Coordinate System button to set the coordinate system. Expand the Geographic Coordinate Systems folder. Scroll down and open the North America folder. Find the NAD 1983. Make sure that you use the plain one and not any of the specialized ones. This is a very common coordinate system, so we will make it one of our favorites. Right-click it and choose Add to Favorites. Then click on it again to make sure it is still highlighted and click OK. Click OK to run the Define Projection tool. Click on the Full Extent button to return to the view of your study area. Now the county line appears on the map. You think you've solved the problem, but we will check against a reliable source to be sure. Click the Add Data drop-down button and select Add Data from ArcGIS Online. In the search box, type Topo and click the Search button. Add the USA Topo Maps map service or layer package to your map. Click the Zoom In button and zoom in close to the county line. Make sure that it falls on or near the county line indicated on the ArcGIS Online map. Then click the Full Extent button to return to the larger view. Double-click the layer's data frame to open its properties, and click the Data Frame tab. In the middle panel under Extent used by the Full Extent command, fill the Other button and click Specify Extent. Fill the button for Outline of Features and select the USFS Roads layer from the drop-down. Click OK and OK again. Click the Full Extent button again. Now it shows the area that you want. Turn off the USA Topo Maps layer for now, but keep it in the map document. In Arc Toolbox, double-click on the Project tool to open it. Set the input data set to county line. Click on the Browse button to set the output feature database. Go up until you see the MGIS data folder, then go into the Black Hills folder. Open the Sturgis 83 geodatabase, and then inside it the features feature dataset. Name the output Law Mead line. Click Save. Click the Browse button to set the output coordinate system. Select the NAD 1983 UTM Zone 13 North coordinate system. Right-click it and choose Add to Favorites so you can use it again later. Then click OK to use it. Confirm that the Project Tool arguments look like this, and then click OK. Right-click the original county line layer and choose Remove. Click on the symbol for the new layer and give it the highway symbol instead. Click on the Add Data button. From the Downloads folder, add the quadrangles shapefile. Click Add. Again, you get an unknown spatial reference warning. Click OK on the warning. Then open the properties for the quadrangles and click on the Source tab. Close the Layer Properties window. Open Arc Toolbox and double-click the Define Projection tool. Set the input data set to quadrangles. Click on the coordinate system and set it to NAD 83 UTM Zone 13. Click OK and then OK to run the tool. Turn on the USA Topo Maps. Zoom in to check the quad corners against the topo maps. Then turn the topo layer off and return to the full extent. Right-click the quadrangles layer and choose Data, Export Data. Click on the Browse button and navigate to the Black Hills folder in the MGIS data folder. Open the Sturgis 83 geodatabase and then open the Features feature dataset. Name the output FORY quads and click Save. Notice the coordinate system setting. Because we're exporting to a feature dataset, the correct coordinate system will automatically be assigned. Click OK to run the tool, and Yes to add the feature class to the map. Right-click on quadrangles and choose Remove. Click on the Add Data button. From the Downloads folder, choose the Township shapefile and click Add. Nothing appears on the map. Double-click the Townships to open its properties and examine the Source tab. This one is labeled as a UTM dataset, but notice the extent, which appears to be in units of degrees, indicating a GCS. Close the Layer Properties window. In Arc Toolbox, double-click the Define Projection tool to open it. Set the input dataset to Townships. A warning icon appears because it already has a coordinate system label. You know that it must be collected, so we will proceed anyway. Click on the Browse button. From your Favorites folder, select the NAD 1983 coordinate system and click OK, and then OK again. The townships now appear on the map. Click on the symbol to open the symbol selector. Give them a hollow symbol, increase its width to 2, and make it a dark green color. Click OK. Turn on the USA Topo Maps. Click the Zoom In tool and zoom in to compare them. They are not as close as the others, but may have been at a smaller source scale. We will use these anyway. Right-click the townships and choose Data, Export Data. They will be automatically reprojected as before. Make sure they're being saved in the Sturgis Features feature dataset and name them Townships. Click OK. Choose to add the new feature class. Right-click the old one and choose Remove. Click on the Full Extent button and turn off the Townships layer. Click on the Add Data button. In the Downloads folder, choose the benchmark shapefile and add it. Note the warning and click OK. Click on the symbol to open the symbol selector and find the triangle 3 symbol. Select it and click OK. Double-click Benchmarks to open its properties and click on the Source tab to examine it. Close the Layer Properties window. In Arc Toolbox, double-click the Define Projection tool to open it. Set the input dataset to Benchmarks. Click the Browse button to set the coordinate system and set it to NAD 83 UTM Zone 13 North. Click OK and OK. Click on the Zoom In tool and examine several benchmarks. This time you notice something odd. The benchmarks appear to be offset from the ones on the topo map. In Arc Toolbox, open the Define Projection tool again. Set the input dataset to Benchmarks. Click on the Coordinate Systems Browse button. Browse in the projected coordinate systems. Expand the UTM folder, and this time expand the NAD 1927 folder. Select the NAD 1927 13 North coordinate system and click OK. Click OK to run the tool. Now the benchmarks are in the right place. In Arc Toolbox, double-click the Project tool to open it. Set the input to Benchmarks. Click for the Output Feature Dataset or Feature class. Save it in the feature dataset of the Sturgis geodatabase. Name the output Benchmarks 83 and click Save. Notice that the output coordinate system is already set because it's in a feature dataset. And notice that a geographic transformation has already been selected for you. Click OK to run the tool. Right-click the original benchmarks layer and choose Remove. Click on the symbol for Benchmarks 83 and give it the triangle 3 symbol. Click OK. Zoom to the full extent of the map and turn off USA Topo Maps. Click the New File Map button to start with a new blank map. Click OK. You can save the changes to the previous map if you wish. Click the Add Data button. Navigate to the MGIS Data folder and open the World folder. Add the country shapefile and click Add. Right-click the country layer and choose Open Attribute Table. Click on the Select by Attributes button. Scroll down to the country name field. Double-click it to enter it in the expression. Click Equals and click Get Unique Values. Find the entry for Turkey and double-click to enter it in the expression. Click Apply to finish the selection. You should have one selected. Close the table. Right-click the country layer and choose Selection. Create Layer from selected features. The layer appears at the top of the table of contents. Click its name twice slowly and rename it Turkey. Press Enter. Click on the Zoom In tool and zoom in to Turkey. Double-click the layer's data frame name to open its properties and click on the Coordinate System tab. In the search box, type Turkey and click the Search button. Expand the Projected Coordinate Systems folder and the Gauss-Kruger folder, and then the Turkey subfolder. Several different zones are suggested, but none of these would be suitable for the entire country. Close the Turkey subfolder and expand the National Grids folder and its Turkey subfolder. A number of coordinate systems are in here, looking like they're based on transverse Mercator. Click a couple of them to see their parameters. Most seem to be based on the transverse Mercator projection, which again is best for north-south zones, not an east-west country like Turkey. When you're done, click Cancel to close the Data Frame Properties window. Recall that the location display shows the latitude and longitude of the current position of the cursor. Put the cursor in the approximate center of Turkey and read off the longitude, about 35 degrees. Then divide it into latitudes of approximate thirds at about 38 degrees and 40 degrees. Double-click the layer's frame name to open the data frame properties and click the Coordinate System tab. Click Add Coordinate System drop-down button and select New Projected Coordinate System. For the name of the custom system, enter Turkey-Lambert Conformal Conic WGS 84. For the projection, choose Lambert Conformal Conic from the drop-down list. Carefully change the central meridian from 0 to 35 degrees. Set standard parallel 1 to to 37.5 degrees. And set standard parallel to 39.5 degrees. The GCS defaulted to WGS 1984, which is fine, so leave it. Click OK and OK. Double-click the layer's name to open the data frame properties. Right-click the new coordinate system in the Custom folder and choose Save As. Navigate to the World folder in your MGIS data folder and save the PRJ file using the suggested name. Click Save. Close the data frame properties. Open your web browser and navigate to the page shown in the text. Examine the coordinate system and try to determine which one is being used. Then click on the full resolution link. Right-click on the enlarged image. If a polygon shows up, simply right-click it again to get the menu to pop up. Choose Save Picture As. Navigate on your computer to your MGIS data folder. Open the USA folder and save the image as NWS radar. Click Save. Once you've saved the radar image, go into Arc Catalog and find it. Right-click it and choose Item Description. Click on the Preview tab and use the Create Thumbnail button to create a thumbnail for it. Click on the Description tab and choose Edit. Enter the basic information about the radar image. Don't forget to put a citation in the credits box so you know where you found it. When you're finished editing, click Save and close the Item Description window. Click the New Map File button. Click Blank Map and choose OK. Click the Add Data button. Navigate to the USA folder. Navigate inside US Data Geodatabase and add the state's feature class. Double-click the layer's data frame name to open the properties. Click the coordinate system. From the Favorites folder, select NAD 1983. Click OK. Zoom to the full extent to see the states again. You can click the Zoom In tool and zoom into the lower 48 states. Switch back to the browser for a moment so that you can compare the shapes of the states. They appear similar, so close the browser window and return to ArcMap. Click the Zoom In tool and zoom into the lower 48 states so that they're showing a similar extent as the map window. You could even reduce the depth of your ArcMap window if necessary. This will facilitate finding control points. Click on the symbol for states and choose a hollow symbol. Give it a high contrast outline so it will show up well against the image. Click OK. From the main menu bar, click Customize, Toolbars, and find the Georeferencing toolbar. Click to open it and place it in a convenient location. Click the Add Data button. Navigate up to your USA folder and find your new radar image that you just created. Click on it and choose Add. You may click Yes if you're asked to build pyramids. Click OK on the spatial reference warning. On the georeferencing toolbar, choose Georeferencing Fit to Display to bring the image into the window. Look at the southwest corner of California and mentally match the corner of the state outline on the image to your feature class. Click the Zoom In tool and zoom in so that you can see both corners. Click Add Control Points from the Georeferencing toolbar. Carefully align the cursor on the corner of California on the image first. Then snap to the corner of the state's feature class. This is your first control point. The images will automatically be aligned as soon as you enter the point, and already it looks much better. Click the Zoom to Previous Extent button. Then click the Zoom In tool and zoom into the New England region. Mentally locate a matching point on the main state boundary. Then click the Add Control Points tool. Click the location on the image first, and then on the feature class. Notice that the control points are being numbered. Zoom to the previous extent. Then click the Zoom In tool and zoom into the tip of Florida. Again, find a good matching point, zooming in a little more if necessary. Click the Add Control Points. Click the image first, and then click the feature class. Zoom to the previous extent, or the extent of the United States. Click the Zoom In tool and zoom into the Pacific Northwest. Click the control points, then click on the image first, and then the feature class. Zoom back to the previous extent of the whole United States when you're done. Click the Zoom In tool and zoom into the boundary between Idaho, Wyoming, and Utah. It already looks well aligned. Return to the previous extent and zoom in to the western edge of Kentucky. Again, the control points look fine, so no additional ones are needed. Return to the full extent of the map. When you're done adding points, click the View Link Table button on the Georeferencing toolbar. Examine your points. You may have more or fewer. Also examine the total RMS error, which is reported for this coordinate system in degrees. If your value is less than about 0.02, then you have done fairly well. When you're done examining the points, close the link table. To save the new coordinate system information with the image, choose Georeferencing, Update Georeferencing. The next time you open this image, it will automatically appear in the correct location. Click on the Search tab to open the search window. If it's not currently here, open it from the main toolbar. In the search window, type Project Raster and click Search. Find the Project Raster Data Management tool and click on it to open it. Click the Browse button to specify the output coordinate system. In the Spatial Reference Properties window, choose Add Coordinate System and Import. Navigate inside the US Data Geodatabase and highlight one of the data sets in there so that the radar image will be projected to match. Highlight it and click Add. Note that the new coordinate system will be North America equidistant conic. Click OK. No green dot appears next to geographic transformation, so none is needed. Scroll down if necessary and set the resampling technique to nearest. Set the output cell size to exactly 2,000 meters and click OK to start projecting. Click on the Add Data button and add the state's feature class from the US Data Geodatabase. Click the symbol, make it hollow, and give it a hot pink outline as before. Click OK. Use it to verify that the projection worked correctly.